research interests include the frictions, including the frictions in product market and its implication on the resource allocation, aggregate productivity, and the trade, the gain from trade, and also including the frictions in asset market and its impact on the monetary policy. I think Chris has done a very profound and influential work in this regards. And today, he's going to talk about new research with Simon Mungy on unbundling labor, talking about the changing skill, occupation, and the inequality. And thank you, Chris, and the floor is yours now.
All right, thank you very much. So thanks for the invitation. I hope you can hear me okay. So this is a joint project with Simon Mungy, who, for those of you who don't know him, Simon was a Melbourne honours student, went to NYU for his PhD and is now junior faculty at Chicago. Good student. All right, so this is a paper about technological change and the implications of technological change for wages within and between occupations. And to kind of fix ideas and the kinds of considerations that are going to be at play, I want you to think about the following example, which is kind of maybe a little bit US centric, as we'll see, but hopefully you're familiar enough with Starbucks that we can kind of proceed. So think about a cafe back in the day in the 50s, 60s, maybe even the 70s, where we have coffee services produced by combining the tasks done by baristas who are operating some kind of espresso machine and tellers who are operating some kind of cash register. So somebody takes your order, your order gets made at the coffee machine, you pay at the till. And what's important here is that the skills being used to make your coffee, there are skills that are specialized on the espresso machine, maybe those are more manually intensive, dexterity intensive, and there are skills using the cash register that may be more cognitive. And we're going to roll forward to like a modern Starbucks, and the machines look a lot more similar, right? So it's like pressing a button on either machine. You press a button on the espresso machine, and you get your different kinds of Starbucks drinks, or you press buttons on the interface for the till, and you get the order processed. And so the point here is that, in a sense, the skill requirements of the technology have become more similar. There used to be a diversity of skills required in these different tasks to get your coffee services, and now there is a kind of more homogeneity of skill requirements. And so, what this paper is going to be about is sort of trying to understand the implications of that kind of technological change. And depending on how we go for time, we may talk a little bit about where such technological change might come from in a kind of deeper sense. So just to be kind of really mechanical about it. So what I'm going to do in today's presentation is I'm first going to tell you about some facts in US data that I suspect are kind of more broadly true. One of these facts I think is pretty novel to us, and the other I think is well known in the literature, but perhaps not well known in general. And then I'm going to talk about the connection between these facts and a sort of theoretical framework that I'm going to present. So fact A is going to be differential changes in skill requirements, or more precisely in the dispersion in skill requirements across occupations. So I'm going to look at occupations. I'm going to kind of crudely classify them into low skill and high skill. And just as a kind of an apology, whenever I say low skill, I really mean low formal educational attainment. So, but that's a mouthful. So I'll just say low skill with apologies for the kind of somewhat inappropriate tone. So low skill occupations and high skill occupations, high formal educational attainment occupations. The skill requirements we see becoming more compressed in low skill occupations and becoming more dispersed in high skill occupations. And then fact B is going to be changes in residual wage inequality within occupations. And we're going to see that there is declining wage inequality within low skill occupations and increasing wage inequality within high skill occupations. And I'm emphasizing that this is within occupation wage inequality, because this is the kind of wage inequality that economic theory usually has very little to say about. So most theories of inequality in economic models is more about between occupations. So it's more about why are doctors being paid more than janitors, right? It's about between occupation wage inequality. We typically have little to say about within, and I'll kind of make that a little bit more precise when we get into the framework. Anyway, there are these two facts that I'm going to show you in a minute. And then our theory is basically going to say that if A occurs, you should expect B. But that is to say, viewed through the lens of the theory, fact A is consistent with A causes B. I'm then going to sort of show you in a theoretical framework how our framework nests a bunch of like standard alternative setups that will basically be silent about what, if any, connection there is between A and B. So crudely speaking, in the literature, A and B may be going on, but we have nothing to say about how they may be connected, whereas in the framework that I present, they will seem to be kind of necessarily or kind of like tightly linked. As I said, depending on how we go for time, I may then talk about how you might expect A to emerge endogenously. So I'll give you like a theoretical extension whereby A, instead of being something that I take as given, becomes something that is sort of endogenous. And if we really, really get through the material fast, I'll come back and talk about a bunch of additional facts, but I suspect I won't get there today. But they're in the slides if you're interested. Okay, so let's get into the two key facts. So fact A is on like skill requirements. So the key point here is that high skill jobs have become more different and low skill jobs have become more similar in terms of their skill requirements. And so how am I going to document this? I'm going to take the US Bureau of Labor Statistics ONET data. So this is basically a matrix of 250 skills and many occupations. So basically in that data, there are occupations like economist and statistician and things like that. And in associated with economist are scores for different skills on a kind of 0 to 9 measure. So we have like a kind of a quantitative, an assessment of, for example, how important analytic skills are to economists and how important statistical skills are to economists and so on and so forth. So we have these measures of skill requirements for different occupations, and we're going to kind of divide it into a kind of before and an after, 2 time periods. And to kind of make this easy to pass, I'm going to follow sort of some existing work in the literature, in particular this paper by Jeremy Lees and Fabienne Postel-Binet, and project down this big matrix of skills to like a vector of 4 skills for each occupation. So just dimension reduction, basically principal components. And that's just going to allow me to kind of think about these kind of, like, it's hard to think about this very, very large dimensional object. This will just be a little bit easier. And then I'm going to measure the distance between an occupation's skill requirements in terms of like the angular or cosine distance between normalized vectors. So if we had 2 skills, skill 1 and skill 2, then I would take like the normalized vectors and look at the cosine angle between them. So this is if I had 2. I've actually got 4, but it's the same idea. So in this metric, 0 degrees means that 2 skills are orthogonal. So they're kind of completely unrelated. 90 degrees would mean that they're, excuse me, I said it the wrong way around, of course. 90 degrees would mean that they're orthogonal and hence completely unrelated. 0 degrees would mean that they're collinear and hence the same. And so we're then going to have a kind of a distribution of these angles for every JJ prime pairing of occupations in the data. And so let's look at what that looks like. So in the left panel, panel A, in blue, I've got the low skill occupations. So these are occupations with below, in this example, below median educational attainment. In panel B, it's high skill occupations that have above median educational attainment. These are kind of like transposed CDF, so like the percentiles of the distribution on the horizontal axis, and the distance measures are on the vertical. The distance measures, as I said, run between 0 and 90, but I've sort of truncated them because you don't see things that are that far apart. And then the solid line is the before period and the dashed line is the after period. So what you're supposed to be seeing is that for low skill occupations, the distribution is shifting down and for high skill occupations, it's shifting up. So there's a kind of a compression of skill requirements in the sense of first order stochastic dominance for low skill occupations, and a kind of an increasing dispersion for high skill occupations. So that's kind of like a fact. And just to be kind of clear on some other details, these distributions are not the raw distributions of occupational outcomes, but I'm weighting them by employment. So basically occupations that have a lot of people, a lot of employment in them, attached to them, those are getting higher weight. There are different ways to kind of weight these things. These kind of results are, not particularly sensitive to things like exactly where I cut, before and after. There are other details like, so this is using a kind of a fixed assignment of occupations throughout the period. So no, you can do it with kind of like reclassifying occupations through the period, or do it on a rolling basis. These sorts of things don't tend to matter for the course fact.
Chris, quick question here. So how do we interpret this percentile?
These are percentiles of the distribution. So like 90 means 90% below. So it's just like a CDF, a cumulative distribution function, transposed. So 90 means 90% below that. So 90 is whatever was the cosine distance of 47 or something, 46 is now like 41, but that means they're 9% below.
It's the distribution of the skill distance.
Yes, within low skill occupations across all. So I classify a set of low skill occupations; those are below median educational attainment, and then I say amongst that set, give me all the give me all the pairwise comparisons, and look at the distribution of that.
Okay, thank you.
And vice versa, similar for the high skill occupations, just with the complementary set of occupations. We've done things again, like you could say, well, let's make, maybe that's cutting low skill sort of to course. We've done things like making it like the lower third of the distribution as opposed to the lower half of the distribution of educational attainment. It doesn't really change this picture very much. So anyway.
Chris, a quick question. So how consequential is this 5-degree change? Say, for example, in the low scale occupation, how consequential is it?
Well, you need some kind of framework to tell you, like, is that a big movement or a small movement? Mm-hmm. So my way of assessing this is that qualitatively, the theory that I'm going to provide says that this should map into implications for wage inequality. So if you then give me your utility function and that wage inequality, I can then tell you how consequential it is. But at the moment, you need a framework to sort of say it's just a sort of, it's really just a statistic.
I see.
So, but you can then once equipped with a model, one could then attempt to kind of, assign some normative significance to that number.
I see.
Another quick question. At the high end of the high skill occupations, can you tell us what's going on there? We're actually getting some tendency toward more uniformity of skill requirements.
I mean, that's not statistically significantly different. So I just basically say at the very, very high end, it's not changing, basically because it's very dispersed. I mean, it's comparatively dispersed to begin with.
Yeah. So I mean, so there is no interesting story about the possibility that very high skill occupations tend to have more conforming tendencies.
Well, it's not that they're more conforming, it's that whatever degree of dispersion there is not changing so much. Right. So maybe it's just like doctors have certain skill requirements, engineers have other skill requirements. The distance between doctors and engineers isn't changing very much.
Exactly. Yeah. Understood. Thanks.
But they may be far apart, but it's just not changing very much at that very high end of the distribution. But
more questions.
The little wrinkle there, I don't much have to say about that particular wrinkle.
One more question.
Yeah.
This may be obvious. If it is, tell me. Who makes these declarations of skills? Is it employees, employers? Is it some government agency?
Yes, it's the Bureau of Labor.
Can they be trusted?
Well, okay, so there's a few things to unpack there. So this is coming from, so ONET is basically coming out of a US National Statistical Agency. So it's put together by public servants who are like looking at data. The input to that data are surveys of firms. So if you're asking like, but at the end of the day, the assignments are kind of a judgment calls coming, but that are informed by surveys. In some very preliminary work, Simon and another co-author, Simon and me and another co-author are kind of looking at skill requirements coming out of like job listings and like job vacancy websites. So kind of like using a completely different measures of skill requirements, like constructed completely separately. And so it'll be interesting to see how robustly this comes out with those, like in principle, completely independently constructed measures of skill requirements. But these ones are, I mean, this is kind of like the industry standard. If you look at people who work in this kind of space in the literature, this is kind of like what everybody does. So the way that the rhetoric here is looking at the same data that everybody else does. Here is a different fact from it that you may not be aware of. And I'm going to, in a few minutes, to try and tease out some implications of that fact.
Thank you.
All right. So fact B, so that was fact A. Fact B is about wage inequality. And this, I think, is, I can go a little bit more quickly because I think it's a little bit better known. So just to kind of fix ideas here, I'm going to look at residual wage dispersion. So as I say, I'm going to look at wages having control for a bunch of observables like industry, education, race, sex, the size of the firm you work for, things like that. Then look at kind of like the part of wage inequality that's not explained by observables, which is not to say that that's the most interesting part of wage inequality, only to say that I don't have anything to say about the stuff that enters the observables. And then what we're going to find is that for residual wages amongst low skill occupations, residual wage inequality has declined, and declined in a particularly interesting way. And the opposite is true amongst high skill occupations. So let's just kind of look at a picture here. So we're going to do a kind of a within between variance decomposition. Blue again is low skill occupations and red is high skill occupations. And so the leftmost panel shows you what's happening to the total variance. The middle shows you what's happening to the within occupation variance. And the right panel shows you the between. And so the first thing to notice is that in terms of total variance, the total variance of like log residual wages has fallen for low skill occupations, but risen for high skill occupations. So this is kind of like a sense that we're going to want to capture later in the theory, that wages have become, in a sense, more similar within low skill occupations. So a kind of, in some sense, a sort of a more homogeneity, like workers look, in a sense, more homogeneous within low skill occupations.
Yeah, Chris, quick clarification. Did you say that you defined this high skill, low skill by education?
Yes.
And then, so you're looking at
so occupations are being classified by the average educational attainment of the workers within those occupations.
Okay,
so I'm not
and then
classifying people, I'm classifying occupations.
Okay, and then here you are looking at the residuals that after controlling for education.
Is that right? Residuals of the individual wages, yes, within occupations so classified. So I might, for example, say that being a doctor is a high skill occupation, but then there's still variation in the educational attainment of individuals within the doctor occupation. Or I might say,
right.
You see what I mean? So that's still it's still a relevant control. Like, for example, I might want to be able to tell the difference. Actually, in these 3-digit occupations, I could anyway tell the difference between like general practitioners and specialists. But in any case, suppose that I couldn't, then I might like that variation in educational attainment at the individual level to help control for that.
Right. So, but I would imagine if you're doing that way, then for those occupations that have very high threshold in terms of education, then you can see much smaller variation in terms of the education at the
But that's why
level.
I'm cutting it at a fairly coarse level. So the high education here is just above the median.
Okay. Okay. All right. Thank you.
It's just like, so there's a universe of occupations, and I divide it into two sets, and I call them low and high. And low is below the median, and high is above the median.
Okay.
I've done other things where I make it like low, middle, high, and excluded the middle, but it doesn't really change what I'm showing you here. And I thought it was simpler just to take the universe of occupations and split it in two.
Can I ask one other quick question? I mean, I would have thought a simple hypothesis for the decline in variance amongst low-skilled wages is the minimum wage law, right? So, and I know in the United States that minimum wages vary by state and so on. But to the extent that low-skilled wage earners have their income constrained by minimum wage laws, then you would expect an increase in uniformity, which is not quite the same as what you said. I think you said that these low-skilled workers look the same. Their skills are becoming more concordant. But it could well be that minimum wage law is making it look that way.
I mean, potentially, but I mean, we're also controlling for things like industry and, you know, like the sector and the firm size. So you would expect those controls to pick up a bunch of like the salience of minimum wages, right? So yes, potentially, it's not entirely obvious to me whether this is whether you would expect, you know, like a binding. Well, in fact, like over this period, we know that minimum wages in the United States are becoming less binding. The real minimum wage, like the distance between the kind of the real minimum wage and like the prevailing market wages is declining through this period.
That's true also for low-skilled workers, is it? I mean, in Australia, there is this tendency to fall back to the award wage rates for comparatively low-skilled workers, right? So, but in the US, you may be right that there's a premium paid, an efficiency wage premium or something like that.
Yeah, but that's about the level. So whatever level there is, what I'm sort of saying is whatever kind of bite is associated with like the minimum wage through this sample, you would expect its salience to be falling because the minimum wage is becoming less binding, you know, is binding on fewer establishments and fewer workers through this.
Okay,
sample.
thanks.
So there are potentially interesting interactions between this and the minimum wage. I don't mean to dismiss that at all. I don't think that's what's driving this pattern. So let me just go back to like what is actually here, because there's some important things I want to explain that will be important to set up the theory. So we have this overall, I've talked about like the overall change in the variance for both low and high skill. But what I want you to focus on now is the relative contributions of the within and the between. So it's true both within and between that the variance is declining for low and increasing for high. But look at the relative contribution of the within occupation variance to the total. This is the piece that standard theory has very little to say about. Most of our models of like the connections between technology and skill prices or wages is about this piece. It's about the between occupation piece. So like if you think about like a Golden Katz, Murphy style race between education and technology, that's all about the between occupation component of wages. Whereas the within occupation is like, why does the 99th percentile of doctors get paid sort of so much more than the 50th percentile of doctors? Why does the 99th percentile of professors get paid so much more than the median professor? And standard theory basically says those people have more efficiency units of something, and so they get more income associated with those efficiency units. So it's a kind of sterile theory. And so one of the things I want to do in this sort of in this project is have a kind of a non-trivial theory of like within occupation wage inequality. And as we'll see, that fact A about changing dispersion in skill requirements is going to naturally map into implications for changing within occupation wage inequality.
Chris, can I ask a quick question? Hi, so I'm just trying to make sense of the two pieces that you have shown so far. So if I were to think about it very simply, if the heterogeneity in the skill requirements for low-skilled workers is decreasing, the low-skilled workers are becoming much more mobile. They can move one sector, occupation and move to the other. That by itself will reduce the inequality in wages within that skill sector. And the opposite would be true for the high-skilled sector.
Yes. So if we had time, I would show you some facts on occupational mobility that seem to support that story.
Okay. All right. Thank you.
Just a quick comment on, in terms of time span, it's interesting to some extent it's sort of contrast to what I expected. It seems there's more change if we look at Yeah, you don't have two periods there.
It's more like here.
Yeah. The perception is more changed in recent decades, right? Instead of the early decades.
Yeah, I agree. The timing is curious.
But maybe you can, I don't know, you just, it's sort of often the perception is that the major changes become more more different, driven by globalization, production network in recent decades rather than early decades.
It could be. Yeah, I don't know what to say, right? This is basically just pure data, and then like whether it is or isn't conforming with people's priors is like, you know, as a good Bayesian, I don't know how to think about that. It should just be moving your posterior, but you know, it's just more data.
Sure.
So anyway.
Yeah, Chris. Yeah, so can I just interrupt and raise one question here? I think a salient feature to me here is just the between occupation dispersion is even lower than the within occupation.
Yes.
So it is because something a control variable you have put into the regression that is correlated with occupation, for example, the industry fixed effects. So that would reduce the dispersion between
so
occupation.
we've got a bunch of controls, like one-digit industry controls and time controls. So that all of that is purging a bunch of systematic variation.
Yeah.
Right.
Yeah.
So you're only looking at the residual variation. So presumably much of that between variation is associated with the sectoral controls.
Yeah, in that sense, actually, that dispersion, for example, across occupation may not be that informative in that sense.
That's fine. That's a fair point. That's a fair point.
Okay. Yeah. So yeah, following this question, then I think it might be better for me, use the word of wage dispersion rather than wage inequality here, because I think several questions, my colleague raised the questions, I think including me, our first impression might be when you talk about wage inequality, you are measuring all of this with this regional wage. But here, actually, what you're actually talking about is a wage dispersion after controlling for so many characteristics.
Yeah, residual wages.
Yeah.
Yeah, I agree. I mean, I don't see the difference between dispersion and inequality. They're just two qualitative words used to describe different like ways of thinking about, you know, variation in the data. I think of them as being synonyms.
Okay. Yeah. Thanks.
Not having other additional. Anyway, so since time is short, let me kind of like park the data and jump into the theory. So what I'm going to do, just to kind of like at a high level, is to write down a kind of a model of skills and skill pricing. It builds on work by Shou and Rosen, by Heckman and Shankman. And I'm going to kind of like, so this framework isn't entirely novel, but I'm going to argue that this framework helps us think about these facts. We are making certain theoretical contributions here. So basically, if I was to kind of say what the theoretical contribution is in a nutshell, it's Rosen / Heckman Shankman in general equilibrium. So these are kind of partial equilibrium frameworks. And so we're going to kind of like do it in general equilibrium, which then makes it easier to think about the kind of like the cross-market effects of changes in technology. So this is going to be an environment where workers are multidimensional in skill. And that multidimensionality in skill is important for thinking about workers who have comparative advantages in different tasks. So there's going to be heterogeneity and comparative advantage, and there is going to be kind of a production side of things where tasks or occupations technologically use multiple skills. And so different tasks or occupations will be differentially intensive in different skills, and hence there will be workers who are differentially suitable for different tasks and occupations, kind of as in a classic Roy style assignment model. We'll see that the standard Roy model is kind of nested as a special case of what we do. And so like an organizing principle here is that while the technologies have diverse skill requirements and the workers have diverse skills, in a kind of fundamental sense, there will be more diversity in workers than there will be in skills. So there will be a kind of partial pooling whereby workers with different sort of different characteristics are all kind of pooling on a technology. So let me kind of like spell this out in a little bit more precision. So it's going to be a static competitive equilibrium model, so no search frictions or anything like that. To keep the examples pretty clear, think about there being two skills, and I'll call those skills X and Y with some distribution H. And there's going to be two occupations with different skill intensities. Now, the two occupations is just for expositional sake. The two skills is important. The two skills, as opposed to say K skills, is just then you'll have an unambiguous notion of comparative advantage. I'll be able to order people in terms of their X to Y ratio unambiguously. And if I had like higher dimensions of skills, that would become more, more messy. In any case, it's going to be a competitive equilibrium model, and the wages that a worker gets are going to be a linear combination of their skills with loadings or skill prices, lambda JX and lambda JY in occupation J. And so an important question for us will be, to what extent is it true or is it not true that a given skill, X or Y, is priced the same in every occupation? So we're basically going to have a friction that I'll explain in a moment that makes it possible for there to be departures from the law of one price for skill across occupations. So your analytical skills may be valued differently in different occupations, or your personal skills may be valued differently in different occupations. So we need some way for that to happen. And then the forces shaping our sort of wage inequality in the model will be the endowments of skills as usual, but then also the kind of the skill prices, these lambda JX, lambda JY terms. So to be like really stark about it, there's going to be some final good that's an aggregate of two task outputs, C1 and C2, and task J is produced with some sort of constant returns to scale production function, and all the examples that I'm going to show you today will be CS of some kind. So there's some elasticity of substitution sigma between the two skills, X and Y. There's some underlying intensity with which, or skill requirement alpha of X in each occupation. And so these X's, capital X and capital Y, are the skill aggregates in that occupation. And the little x's are the skills supplied by individual workers. And so the critical friction for us is going to be that workers are not divisible, that when you choose an occupation, you have to supply your whole bundle of skills to that occupation. You cannot separately assign or separately sell your analytic skills to the economics department and your personal skills to, the psychology department, right? You have to sell all of your skills as a bundle to the same occupation. And what that's going to mean in equilibrium is that there are going to be certain circumstances whereby people whose comparative advantage is a particularly good match for their occupation are earning quasi-rents compared to workers with lower comparative advantage for that occupation. So it's going to be a little bit like, just to kind of like set sort of the theme of this analysis, it's going to be a little bit like Heckscher-Ohlin trade theory. So imagine like a Heckscher-Ohlin model where capital and labor are distributed across countries. Capital and labor are not mobile, but nonetheless, under certain circumstances, we get factor price equalization because trade in divisible goods, as long as the distribution of endowments isn't sufficiently adverse, trade in divisible goods is sufficient to recover for us factor price equalization. So as a sort of a flavor of the same result. Under certain circumstances, occupational skill prices will be equalized, even though there's a kind of a friction preventing their mobility. And under the circumstances, they won't be. And like a key part of the analysis will be understanding when and when not these things hold. So as I said, workers must allocate their XY bundle to the same task or occupation. And then to think about like the equilibrium here, I'm going to start by thinking about like a planning problem. So this environment is going to be constrained efficient. So the allocation, the equilibrium will coincide with like the solution of a planning problem. as long as a planner respects the same friction, same assignment friction. So think about like the efficient allocation here, where a planner is maximizing final output subject to the technologies. Then the skill prices, if factors could be frictionlessly allocated, the skill prices in each occupation would just be given by their marginal social products. So for example, the skill price of skill X in occupation 1 would be the marginal value of occupation 1 times the marginal product of skill X in occupation 1, like this. So if skills could be divisibly allocated, so if I could send my skills X and Y to different occupations, so there's no friction, then what would happen is that skill X would have the same value in both occupations, and skill Y would have the same value in both occupations. These things would be equalized by a kind of no arbitrage argument, right? And since people are, under this kind of counterfactual, people are divisible, and so that's feasible. And so what we want to do now is say, well, let's take this problem and now impose upon it the additional restriction that you have to send your skills to the same occupation. So that's then going to create some wedge or gap between these skill prices, at least under some circumstances. So a technical contribution of the paper is to say, look, here is this problem that has like a continuum of constraints with a continuum of Lagrange multipliers attached to it, and a slightly like difficult to interpret set of optimality conditions. You can compute the solution to this problem by studying a kind of a auxiliary stand-in problem of the following kind. So it's a kind of a result in the paper that one can replace this continuum of individual level bundling constraints with a single, or actually more precisely, a pair of constraints that are stated in terms of skill aggregates. So we're going to turn out to be able to replace this continuum of person by person constraints with a constraint of the following form. And so let's take a little bit of time to sort of understand what this constraint says. So X1 is some hypothetical allocation of skill X to occupation 1. So that's some number. Where that number comes from for the moment, we leave aside. But suppose that you were to allocate skill aggregate X1 to occupation 1. Then the constraint that we derive is that the amount of skill Y that goes to occupation 1 must lie between two numbers, B lower bar of X1 and B upper bar of X1. So for each X1, there is a bound B lower bar and a bound B upper bar, such that the corresponding amount of Y that gets allocated to occupation 1 must lie between these two numbers. So let's think about like what these bounds look like and how they're constructed. So I'm going to order workers in terms of like the highest X to Y ratio. So basically I'm looking at workers whose comparative advantage in occupation 1. So occupation 1, I should say, is kind of hungry for skill X. I'm going to order occupations in terms of their intensity in the use of skill X. So occupation 1 is the occupation that's most intensive in skill X. So now let me order workers in terms of their X to Y ratio. So the worker with the highest X to Y ratio has got the most X relative to Y. So they've kind of got the, loosely speaking, they have the most comparative advantage in occupation 1. So then what I do is I say, you tell me the X1, the capital X1 you want in occupation 1, and I'm going to construct that by using the least amount of Y possible. How do I construct that by using the least amount of Y possible? I just take the X's ordered in this way up to the I star, such that the integral of the little x's gives me the capital X that you stipulate. So since the skills are bundled, with every little xi that I bring in some y of I. How much y of I do I bring in from 0 to I star? And so that's giving me amount b lower bar of x1. This is in units of y. So that's the least amount of y that I can bring in if I rank people in terms of their comparative advantage for this occupation and bring people in starting with the best comparative advantage for this occupation. And that would give me my lower bound, the least amount of Y that I bring in, and you do the parallel argument and you figure out the most amount of Y that you can bring in. And the actual amount of Y must then lie between the least and the most. And as a kind of a result, proposition, if you like, that constructing the bounds in this way and solving the optimization problem with those bounds is equivalent to solving the original problem, stated in terms of these individual level continuum of individual level constraints. Okay.
So Chris?
Yes.
Yeah, so can we understand this lower bound of Y, B low bar, as a efficient allocation of Y conditional on the allocation of X?
No.
Not?
It's about feasibility, not efficiency.
Okay.
So I'm going to tell you a lot more about this in a few seconds. So you just hold that thought. It can't possibly be about efficiency because I've said nothing about the technology here. I've only really invoked properties of the labor supply, the skill distribution. So without knowing anything about the technology, except possibly the ordering principle that occupation 1 is the one that wants skill X, but without using any other features of the technology, how could you know whether it was efficient or not? Anyway.
Yeah, Chris. So these two skills in your setup, is it right that they are perfect substitutable to each other in
No,
terms
absolutely
of?
not.
No. So what's the relationship between these two skills in terms of completing the same task?
In terms of which, sorry?
So if you have two skills,
Mm-hmm.
and then you can bring two skills to do one task, what is the relationship between these two skills in general?
Maybe complements or substitutes, but it's unspecified at the moment.
Okay.
It will turn out to be important whether they're complements or substitutes. It will turn out to be important, but I'm kind of like trying to hold off on that because it's not important yet, but it will become important when we start to think about comparative statics and the signs of effects. But for now, to understand like the structure of the model, it's not important.
There's a quick question about the assumption. I'm still hung up on it. It looks like a pretty good depiction of the high skill sector, but in the low skill sector, to what extent can workers not disperse their skills across different jobs, right? I mean, take the gig economy for that matter. One day a low skilled worker could be driving an Uber, and the other day they could be babysitting.
But when I drive an Uber, I bring all my skills to Uber driving.
Mm-hmm.
And so imagine that I kind of like do, I work like shifts at a restaurant or a bar or something on some nights, and I drive Uber on other nights. So if driving Uber requires a different, like a slightly different skill set, like slightly more cognitive skill set, and like waiting tables requires a slightly different skill set, like more stamina, more sort of physically demanding, then in each case, I'm taking my whole bundle of skills to that task. And it may be that some of my skills are not being fully utilized or not being utilized to the same extent in one task versus the other, but I'm always taking all my tasks or my skills to that task when I'm doing that task.
Yeah, that makes sense.
Okay, so I need to kind of keep blasting forward since I'm on page 12 now. So you're asking great questions. That's good. So let me kind of do it like this. If the skill distribution is kind of smooth, then the bounds look like this. So this is like the B upper bar and the B lower bar. I'm going to see a lot of diagrams like this in the next few minutes. So let's understand. So I've got the aggregate endowment of X lower bar and X upper and Y on the X and Y axes. I've got what I'm measuring on the horizontal axis is the amount of X that's going to occupation 1. And then like in Edgeworth box fashion, the residual is what's going to occupation 2, and vice versa for skill Y. So this starts off flat like this because I'm initially putting in to occupation 1 people with the highest amount of X and the least amount of Y. So if somebody's got like nearly 0 Y and a lot of X, then that gradient is very flat. But as I start bringing in people who've got more and more Y relative to their X, then I'll get this increased, I've got this convexity. So basically that convexity in the lower bound reflects like diminishing returns to selecting people in terms of their comparative advantage. By construction, there's diminishing returns to selecting people in terms of their comparative advantage. So in this box, the way that you should understand it is that if there was no bundling constraint, the whole box would be the feasible set. We don't know what would be efficient, but everything in the box would be feasible. In the presence of the bundling constraint or bundling friction, the whole box isn't feasible. Instead, what's feasible is this green football lens. Okay.
But isn't this graph showing you this positive relationship between, so you stay on the same bar, upper or lower, they both move in the same direction.
Well, that's always the case, right? Because if I add people who've got some X into occupation 1, they have non-negative amounts of Y. So every time I add somebody with X into occupation 1, I bring a non-negative amount of Y into occupation 1, then I'm necessarily increasing both at the same time.
Okay, so it says nothing about the relationship between the two. It just
This is something about the aggregate relationship between the two in terms of the assignment.
Yeah.
So
Okay.
perhaps the question you have in mind is going to be answered by the following picture. So in the right panel, the lens that we saw before, the left panel is the actual underlying distribution of skills that was used to generate that, or like a sample from that distribution. So this is a case where the underlying skill distribution is independent. So the X and Y marginals are independent. And it's going to give me this lens. So there are individuals who've got like a lot of X and very little Y, and others who've got a lot of Y and very little X. Those individuals are out there. That's fine. The panel on the right is about the aggregate relationships, not the individuals. Nonetheless, there is a connection between the underlying distribution of such skills and the shape of the lens. So let's see if we can figure out what that relationship is. So imagine that the skills, the distribution of skills in the population was positively correlated, right? So that if you have somebody who has a lot of X, they tend to have a lot of Y. Or if they have a lot of Y, they tend to have a lot of X. So then the distribution of individual skills is going to be more like this blue scatter in the left. And what is that going to do to the lens? It's going to shrink it. Why does it shrink it? Well, positive correlation is kind of here the enemy of comparative advantage. Positive correlation says if somebody has a lot of X, they statistically tend to have a lot of Y. So people who have a lot of X and little amount of Y are very rare. So that it's hard to kind of shoot off this way. You instead shoot straight up or nearly straight up. In the limit, if everybody had the same X and Y, so absolutely perfect, correlation. Right? Sorry, I should say, if everybody's X and Y were proportional to each other, and it's only a matter of how many of them you had, then there'd be no way to use comparative advantage to select people. So in that limit, the lens would collapse to a straight line, the diagonal line. So positive.
The scatters on the left are real data, or they're synthetic data that you've generated?
Just simulation.
They're simulation.
It's just to illustrate the shapes.
Right.
No, it's in fact, obviously it would depend what the skills were as to whether they're positively or negatively correlated and what level of aggregation you were thinking about. So I'm just trying to illustrate like the economics. So positive correlation is like the enemy of comparative advantage. The friend of comparative advantage is negative correlation. So if you have a lot of X, you tend to have a little amount of Y and vice versa. So that's going to give you this kind of shape in the scatter. And what that does is expand the feasible set, right? Because then it becomes relatively easy to find people who've got a lot of X and little Y or vice versa. So it's relatively easy to go a long way this way before the convexity starts peaking.
So how can we relate this to, I'm not sure if you have any distinction between skills and ability. So if you have this negative correlation and positive correlation, can we imagine that if you have a positive correlation and you're moving towards the right corner, up the right corner, you are some sort of people have higher ability, and in contrast to
ability is more about the level.
The level.
ability is more about like out here.
Yeah.
So that's about the level. So in this world, like it depends a little bit on how you think about it. It's much easier to think about ability in a positively correlated case, because then there's just people with, there's people with a lot of X and Y, or people with a little X and Y. X and Y is positively correlated, and there are some people who've got a lot and some people who've got a little. And then ability is just like about the magnitude of that vector as opposed to its composition.
Yeah, indeed. Yeah. So when you fix,
you have negative correlation,
yeah,
you then think about like how are you like averaging over the two coordinates more seriously. And that's presumably you'd want a model to think about what is the right way to do that.
Right.
But there's a much less ambiguous, like, it's just like they're more incommensurate, right? So if you've just got like, two different skills, playing a musical instrument, solving models on a computer, they're very, very different. How do you say who's got more ability? Well, if the skills are very different and people have like very like negatively correlated distributions of those skills, like saying who's got high ability is a little bit more, obviously depends upon the framework that you have in mind.
Right.
You see what I mean?
Yeah. Yeah.
But the more similar the skills, or the more kind of they tend to go hand in hand in terms of their distribution in the population, the easier it is to unambiguously say that person's high ability and less otherwise.
Yeah.
Yeah,
Okay.
so Chris, can you just intuitively explain why here it is a case that the negative correlation, this feasibility set is closer to the Edgeworth box
I thought
when the two factors are totally separable, rather than it is uncorrelated?
I thought I just did, but I'll say it again. So negative correlation means that it's statistically likely that there are many people with high X and low Y and vice versa. And the bounds are constructed by taking people with the most X to Y ratio first, followed by people with fewer, with lower X to Y. So when there's a lot of negative correlation, it's easier to move this way without increasing. It's easier to take a lot of X into occupation one without taking very much Y, because there's a lot of people who have got a lot of X and very little Y. And it's comparatively difficult to do that if in a sort of the case of positive correlation, because everybody who's got a lot of X has also got a lot of Y. So you necessarily drag into occupation one some Y whenever you drag in X. So I'm barely, time is marching on. So I'm gonna, maybe what we should do is like, let me get through some preliminary, like basically finished outlining the model, and then gather any questions at that point, if that's all right. Just to kind of, because I feel like I haven't really said like the key parts yet. Okay, so we can then study this problem in terms of the aggregate bundling constraint. Come back to our original planning problem. If you think about the economics here, there's two constraints, but they can't both be binding. Like either the equilibrium is kind of going to be pulling us in one direction or the other. And so generically, it won't be the case that both constraints are binding. Maybe neither of them is binding, but they certainly can't both be binding. So I'm going to kind of rank things by thinking of this being the potentially interesting constraint. That's really kind of like a presentational choice. So if you then look at the first order conditions associated with this problem, you'll see that there is a multiplier on that constraint times a term that reflects the curvature of the bound. And that curvature of the bound, via the inverse function theorem, is a kind of a measure of the comparative advantage of the marginal worker at that candidate solution. So let's look at these first order conditions. If the bundling constraint was slack, so the mu was 0, then this would just recover for us the law of one price for skills. But if the bundling constraint is binding, so mu is positive, then what that says is that skill X in occupation 1 earns some premium over and above skill X in occupation 2. What is that premium? This much. So this is the premium that skill X earns in occupation 1, and vice versa, skill Y earns a premium over in occupation 2, earns a premium over skill Y in occupation 1. So in this presentation, it's implicitly assumed that occupation 1 wants a lot of X and occupation 2 wants a lot of Y. Hence, there's a premium to each skill in its primary occupation. given by these terms that are proportional to the multiplier. So this multiplier on the bundling constraint is like the wedge between occupational skill prices. And the question is that wedge 0 or not? So let's now understand like what role technology plays here. So let's think about like the technological contract curve. So this is the isoquant of equalized marginal rates of technical substitution. So that's this blue line that I'm drawing. And suppose we had, now let me kind of step back for a second. The contract curve here, the technological contract curve, is purely a feature of the technology, the production functions. It's got some curvature that comes from those things. It's independent of the skill supply. The green lens is entirely determined by the skill supply. It's independent of the technology. So we can do two kinds of comparative statics here. We can move the technology around, holding fixed the lens, the green lens, or we can move, the skill supply around, holding fixed the technology. And so those gives us our kind of like a dichotomy of comparative statics. For the moment, let's think about fixing the lens and moving the technology around. So I've initially drawn the technology by fortuitous chance such that the contract curve runs through the lens. So in this situation, there'd be an efficient allocation here, and that efficient allocation would be supported by a uniform skill price ratio reflecting equalized skill prices in each occupation. So the planner or the market can't get better value for any given worker by moving them from one occupation to the other. So all of the kind of the gains from reallocation have been exhausted, and this is what we have. So that's one possibility, maybe, that the contract curve does look like that. What if it looks like this? So this is a contract curve that happens to lie outside the feasible set. So what happens then? Well, if you look at like this piece here, you see what looks like a core, like the core in an Edgeworth sense, the gap between two isoquants. And it looks like there's gains from trade, right? It looks like I could move some X into occupation 1 and some Y into occupation 2 such that the output would be higher. But I can't, because all of those variations are infeasible. They would require like breaking people open to get at the underlying skill content. We can't do that. We have to respect our feasible set. So the best we can do is this. If you think about the geometry here, it's kind of like the closest you can get to where you want to be, subject to feasibility. So there's like an inward pointing normal argument, but I'm not going to go into that right now. So at that point, you're on isoquants that have different slopes. And so those slopes reflect different skill prices. And the gap between those slopes is the multiplier on the bundling constraint. But for now, there's just some gap, right? So reflecting the fact that skill X is relatively valuable in occupation 1 and skill Y is relatively valuable in occupation 2. So then I'm just going to jump forward a bit, come forward, do it in a couple of slides, in one slide. Think about then some technological shift that would drive up the returns to skill X in occupation 1. So in this diagram, that would be like some shift that pushes the contract curve this way. So that would drive up the value of skill X in occupation 1 and drive up the value of skill Y in occupation 2. And so if you think about what that's doing to wages, so I've written log wages here, like just rearranging terms, log wages would have a constant intercept, a kind of an individual level characteristic, and a piece that depends upon interactions. It depends upon the product of your comparative advantage and the skill price gradient. And so if you've got forces that drive up the skill price gradient, you're going to amplify the return to comparative advantage in that occupation. So individuals who have a lot of X to Y and are in occupation 1 where X is really valuable are going to earn a Marshallian quasi-rent, right? So it's not a profit in the sense of like some market power or failure of some kind. It's just a quasi-rent associated with this kind of like the quasi-fixed nature of their factor supply.
So Chris, maybe I missed it. So, but what's the cause for the deviation between the competitive equilibrium and your efficient state? So your
well, it is a competitive equilibrium. It is a competitive equilibrium, and it's constrained efficient. And the only reason it's not equal to the frictionless competitive equilibrium, it is a competitive equilibrium, but the only reason it's not the absolutely frictionless competitive equilibrium is the fact that you have to send the two skills to the same occupation. So you can't get to choose. So there's these constraints in the individual problem and reflected in the planning problem that say any individual worker, whatever their skill endowment X and Y is, they have to supply their X and Y to the same labor market, same occupation. They can't send them to different locations if you want to think about it like in a physical sense, or they can't send them to different occupations.
Okay.
Implicitly, our standard theory says that you can. There's no such constraint.
Because that would be true only in this static model, right? I mean, dynamic world, the lens could shift towards where the contract curve is. If people, train on the job or invest in skills that are valued more, or the contract curve could shift in as well if firms were smarter about how they use technology.
Yeah, sure. Both of these things are true. Absolutely. Okay. In the paper, the comparative statics that I just walked you through in terms of those diagrams are spelled out with more precision, but given time, I'm just going to kind of skip over this. Just to kind of like be super kind of clean about it, or clear about it, I should say. This is the kind of the thought experiment here. So remember alpha is a measure of the intensity of skill X in occupation 1. So imagine that I start off with a kind of a technology that's like neutral with respect to the skills, like it requires X and Y in the same proportions, and I gradually increase the importance of skill X in occupation 1. So what that's doing here is it's sending the contract curves this way. So this is the technological change that you just alluded to. And I've started things off inside the bundling lens. So the multiplier is going to sort of start off at like 0. And then as I shift the contract curve by increasing alpha, at first, nothing is happening to the variance of log wages. And it's because this law of one price for skills hold, and people are getting different wages based purely on their endowments of different skills, and those skills are remunerated equally in either occupation. But once I get my my alpha to this point here, to this point here, or here, then the multiplier starts to bind, and then from that point thereon, wage inequality starts to rise. So you can think about an increase in wage inequality very crudely as a movement in this direction, and a decrease in wage inequality in a movement in the other direction. So with a kind of a reduction, so an increase in like the specialization of skill requirements, that's alpha getting higher, is associated with higher within occupation wage inequality, and a decrease in alpha, so a decrease in the, so an increasing similarity of skill requirements is then associated with a movement in the other direction, namely a movement towards decreasing wage inequality. So these things we've sort of spelled out. So just to kind of come back to our sort of initial sort of motivating example, the way that you think about this is that you think that in this earlier period, we had very diverse skill requirements. So like high alpha, kind of a sorted equilibrium with binding bundling constraints and relatively high wage inequality. And then as alpha falls, so that the skill requirements become more similar, those things are undone. In the 10 minutes or so that are left, I want to do two quick things. I want to spend 5 minutes talking about some special cases to see how sort of our standard frameworks fit in here. And then I'd maybe spend 5 minutes talking about the role of substitutes and complements. Okay. So 3 special cases. So by Katz-Murphy, I mean like Katz-Murphy's QJE paper with like low and high skill workers. So that's kind of a special case here in the following sense. Now let me call my X and Y skills L and H, low and high. And I'm now going to think about there being 2 types of workers. There are types of workers who are either L and 0, so they're low skill workers, and there are types of workers who are 0 and H, they're high skill workers. So if this is your framework, so that everybody's got some L and a 0 or got some H and a 0, then implicitly, this is a situation where the equilibrium is always unbundled. You've constructed a skill supply distribution such that it's impossible for the bundling apparatus to play any role. And that is to say, because people are L's and 0s or 0s and H's, if you take some L to the market, you never take any H. So that there's no artificial scarcity attached to the fact that there's some H bundled with you because it's 0. Or if you take some H to the market, but you're 0 for L, then there's no artificial scarcity created there either because you're 0. And so for each skill, it's still going to be the case that wages are given by this linear combination. It's just that people are 0 in one coordinate or the other. And hence the variance of their wages is just going to be given by the variance of their endowment of skills. The variance of their log wages is going to be the variance of the endowment of their skills, with nothing to say, with comparative advantage playing no role. So in terms of our diagram, the Katz-Murphy type high-low situation looks like this. You've got a contract curve that comes from technology, but the skill supply distribution is like the whole Edgeworth box is completely filled out because there's no tension. Everything you can achieve any point you want just by picking out the relevant combinations of workers, and you never face any kind of trade-off coming from the fact that this is bundling. At the opposite extreme is a Roy model. So by a Roy model, I want to generalize things a little bit. So now let me think of my X and Ys as themselves sufficient statistics for some underlying bundle is perhaps the wrong word here, for some underlying list of characteristics Xi. So now instead of there being 2 skills, there's just a sufficient statistic for some vector of skills. And this skill X is used only in one occupation, and there's a kind of you might think in the background, there's some other skill YI that's like the X but beta Y, comma. So some other mapping from those characteristics. So this is going to be a world, to cut a long story short, where the skill supply is what it is, but the technology is extreme. So whereas Katz-Murphy gives you a world where the equilibrium is always unbundled, the Roy model gives you an equilibrium where where things are always bundled, right? The contract curve is always this backwards L shape, and the solution is always at a point like this. Now, we don't normally think about constructing solutions to the Roy model like this, but this is implicitly what's going on. And so in this sort of world, whenever I take my skill X to occupation 1, I've implicitly got some skill Y, and the skill Y is just not valued in occupation 1, and vice versa for occupation 2. So the Roy model is like a special case where these things are kind of like a trivial in the sense that the equilibrium is always bundled. So what we're going to have here is something that kind of intermediates between these 2 extremes. So to a first approximation in our model, wages can be written like this, where these coefficients, these beta tildes, are a weighted average of the underlying Roy coefficients, the beta x's. And where this lambda 1 tilde thing is basically in 1-to-1 correspondence with the skill prices. So lambda 1 tilde, there are some weights between 0 and 1 that reflects the relative value of skill X in occupation 1. And in the special, in like this, the standard Roy model, lambda 1 Y would be equal to 0. So lambda 1 tilde would be equal to 1. And so the beta 1 tilde would just be equal to technological beta X. So what we've got here is a situation where there is like an endogenous reweighting of the relative values of the skills. So instead of the prices of skills being locked down by these betas that are kind of external to the model, they have relative values that like enter wages through this composite endogenous coefficient. And only in particular special cases does this thing collapse to the kind of the usual framework. And so what that means is that if there's some shock, if there's some technological shock or other kind of shock that changes skill prices, it will endogenously reweight the values of the different skills through this mechanism. All right, I will skip Lindenlaub. Let me say something about technology. And like, I'm now over time, or nearly over time. But let me just kind of finish this last topic off. So you might then ask, where do these changes in technology come from? And so an experiment we do in the paper is to think about a kind of an extension whereby we allow firms to optimize their technology like relative to like the market conditions that they face. And we allow them to optimize their technology by choosing these factor augmenting terms, these AXs and AYs in their production function subject to a technology frontier. So this is a kind of like a new step. And the way that you should think about this, so let me draw a picture. So the technology frontier looks something like this. So backwards bending frontier. So think about like an initial short run equilibrium where the technology frontier is like some backwards Leontief thing. So that's basically saying in some initial short run equilibrium, you can't change your technology. It's like locked down. But now let me kind of relax the sort of the curvature here. So relax this parameter rho. And as I relax it enough, the technology frontier is going to become linear. And I can choose any of these factor augmenting coefficients in this like enlarged space. And so what this is going to do is basically kind of think about comparing like a short run equilibrium where your technology is just given to you, that's like this, and a kind of a long run technology where you've optimized your production function relative to the market conditions, but then where the market conditions have to be kind of consistent with those choices in a kind of fixed point way. Okay. So what we're then going to find is that the elasticity of substitution in the underlying production function is the critical determinant of which way the long run technology goes and what implications that has for wages. Let me see if I can do this in some pictures. This is just technological junk. Okay. So now I'm going to use these pictures to walk through the comparative statics. So case one is going to be where the skills, the X and the Y, are substitutes in production. So the sigma is positive. Okay. So sigma equal to 0 is Cobb-Douglas in production. So sigma greater than 0 means that they're more substitutable than Cobb-Douglas. And so what I've drawn here is like the initial like exogenous technology, and then we're then going to compare what happens when I allow the technology to kind of adjust in the long run, to kind of be optimized by firms relative to market conditions, but where the market conditions then need to reflect the technology chosen by firms. Okay. Well, in this case, where sigma is positive, the technology that firms want to choose is out here. The contract curve shifts out. But since we started in an equilibrium in this example that was already bundled, all this does is further tighten the bundling constraint. So it's like here, what the firms want to do is to have a technology that's more Roy-like, that's more bundled, right? So that where the bundling multiplier is higher. And I think this is not intuitive for lots of people, because I think a lot of people would, the intuition would be something like this. You've got this bundling constraint, and now allow people to relax this by choosing a different technology. So why could it be the case that the bundling constraint might bind more, might be tighter? Well, the answer is that you can get more output, that TFP would go up. So you as a firm would be potentially quite willing to choose a technology that involves a tighter bundling constraint and paying higher wages to some of your workers, if as compensation for that, you're able to produce more and to operate with a higher level of TFP. And the planner would, that is this allocation is constrained efficient. That coincides with the planning solution as well.
But wouldn't that also change the supply of skills? Like, you're bound to complete change. Once it's going to take time. I know you're a static model, but once you change the wage ratio to different skills, then it's going to provide incentive for workers to acquire,
yes,
different skills.
So absolutely agree. That's a great question. That's just such a great question. That is Kevin Murphy's unpublished PhD thesis. So the reason I'm not studying that here is because that is the problem that he takes up in a kind of partial equilibrium version of this setting, where you have this kind of Rosen-Henkman-Schenkman lens, and then he allows individual workers to acquire different amounts of human capital facing market prices. What he doesn't have is the firm side demand and the kind of the interactions with technology. So it would be interesting for somebody to kind of like put these things together. Completely agree. Okay. Completely agree. But there's a reason why I didn't study that version of the problem. It's because it's already been done, at least in large part. So to be clear, like what is the intuition for why, sigma being positive is associated with tighter bundling constraints under the endogenous technology? Well, it's when skills are substitutes, you can dispense with the one that is less productive for you, right? The whole idea of them being substitutes is to say, well, if X and Y are good substitutes and X is more productive than Y, then reduce my reliance on Y at all. Make my technology more specialized in X. And that takes the contract curve out towards the southeast quadrant and tightens the bundling constraints. By contrast, if we look at the case, let me just kind of cut to the chase here. If we look at cases where the skills are complements, starting from the same initial position, but with skills that are complements, then the technology that firms choose will move inside, right? And the reason, of course, is that when skills are complements, your X and Y skills are complements, you as the firm, you want to reduce your exposure to the weakest link, right? Like if one of these skills is less productive than the other, but they're complements, then you try and fix the skill that is less productive. If you've got a left shoe and a right shoe and the left shoe doesn't fit you properly, you fix the left shoe and you make its kind of value to you kind of comparable to the right shoe. So when the skills are complements, the technology the firms choose has a contract curve that's inside the lens. And then what that's doing is it's relaxing the bundling constraints. In this particular example, it completely obliterates the bundling constraints and reinstalls the law of one price per skill, thereby reducing the dispersion in wages. So the unbundling labor of the title is the fact that when skills are complements, long-run technological change is a force for making the returns to the skills more similar across occupations endogenously, right? So, instead of invoking some change in, we could of course get unbundling of labor by invoking a change in the skill supply. And there's a kind of a paper out there that I can point you to that does that. But here we're kind of getting that, if you like, through the technology rather than through a change in the skill supply. All right, I'm a little bit done for time. Thank you all for your questions. I apologize for maybe being a bit long-winded in places. But if you've got any other kind of clarifying comments, I guess now's the time to quickly address them.
Yeah, thanks a lot, Chris. I think, so if you can stay here for a few minutes, absolutely. I think we still have some questions or comments. Yeah, so anyone would like to, to